Hello. Today we're going to be working on entering matrices into our calculator. So a lot of what we have been doing can also be done using our calculator by using the matrix feature. So on your graphing calculator, here are the step-by-step instructions. You can go ahead and enter in different matrices on your calculator by following these. So I'm going to zoom out so we can see everything here. So your matrix button is going to be right above this key right here. So you're going to hit second, matrix, and here's where you're going to do everything. You can see all the names of your different matrices. So in order to actually enter them, you have to go over to edit. You're going to hit enter, and you need to type in the dimensions. So here I'm going to correspond my A, B, C, D, and E with the ones that I have on the notes here. So A is a 2 by 3. So you hit 2, enter, and then 3, enter, and then the calculator creates a matrix of that dimensions for you. Then you're going to type in all of your different entries. So you're going to, after every single one, hit enter. So 2, 3, 5, enter, 4, -1, make sure you're using your negative sign, not the minus sign, and then 7. So take a moment here and go ahead and enter all of the other matrices on your calculators, and then unpause the video to keep going. So by now, all of your different matrices should be in your calculator. So to actually do a problem like example 1A, what you're going to do is you're going to quit out of your matrix, whatever one you're in. So you should have your normal home screen for your calculator. Then to enter something like D times B, you're going to go second matrix, and you're going to go down to D, and it should pop up as matrix D there. And then you're going to do second matrix and go down to B and hit enter, and you're going to do D times B. When you hit enter, your calculator will do all of the matrix multiplication and give you your answer there. So all that's left is for you to go ahead and take that and write down all of your answers. So let's go ahead and have you go ahead and try B and C, type those in on your calculators, and then come back here to see what we get. So we can see that when we do B times D, we get something that does not exist. And then for C, when we do 2A minus B, you can see the resulting matrix there. So your calculator can do addition, subtraction, and multiplication, but it also can do what we have recently done with the determinant. Woo, there we go, the determinant. So remember notationally, our determinant can be notated by DET or by using something that looks like those absolute values. Okay, both of these are referring to finding the determinant. So what you want to do is you want to enter your matrix on your calculator. Then we're going to hit second matrix to get back to it. And so looking at our calculator here, we're going to hit second matrix. Now we don't need the name of it right now. We also don't want to edit it because we're using matrix D from our previous example. So what we're going to do is we're going to go over to math. So your next step is to go over to math. And then when you're there, you can see all of these different things that your calculator will do for you. So what we want is we want the determinant. So you're going to hit enter for your determinant, and it should come up as DET. And then you're going to enter the name of the matrix. So for instance, this first one, we wanted matrix B. So we're going to hit matrix, no, D, not B. So matrix D. And your calculator will do all of that for you and tell you that the determinant of D is -2. Okay, so go ahead and calculate the determinant for matrix E. And we should get -60. So that's a little bit about using our calculators. And we will be using our calculators for our next skill that we want to do. So we want to be able to find and solve different matrices. And the way we do that is by using something called an identity matrix. So an identity matrix has to be a square matrix, so 2 by 2, 3 by 3, 4 by 4. And 1 is going to be the only data entry other than 0, and it's going to always go along the diagonal. And all other data entries end up being 0. So these are all identity matrices. And what we do is we call the identity matrix I. The identity matrix is important because it helps us to identify inverse matrices. Now, you've heard of inverses before. So, for instance, if you had 2x equals 4, you would divide by 2 because the inverse of multiplication is division. Those are inverse operations. So, inverse matrices are two matrices that when you multiply them together, they completely undo each other, and your resulting matrix has to be an identity matrix. So let's go ahead and take a look at these two. You can either multiply things by hand, so 5 minus 4 is 1, or if you'd like to type these in on your calculator, that also works. So either way, go ahead and calculate this one. And looking at these, we end up with this 1, 0, 0, 1. So ones are down our diagonal and zeros are other entries. So we end up with an identity matrix here. So what happened here is if we multiply A times this matrix, we get our identity matrix. That is known as the inverse of A. These two are inverses of each other. And the way we show notationally that something's an inverse is it looks like it's to the -1 power, but it's not. It's standing for A inverse. Okay, so be careful because this -1 here means inverse. It does not mean A to the -1st power to move it to the denominator and call it division. That's not what it means. Now, something interesting about inverses is if you have A times A inverse, you get the identity matrix. But also, if you do the inverse first times A, you will still get the identity matrix. So, if you have A times B and B times A, and you both get the identity matrix, it works. Those are inverses. Okay? So let's go ahead and talk about how we find an inverse matrix. Okay, say we are given a random matrix A, and here we have a 2 by 2. So the inverse of this matrix is notated by A -1, so the inverse of A. The first thing is to find the determinant of A. And we're going to do the reciprocal of the determinant. And then what happens is A and D, those data entry points, switch spots, and B and C stay in the same spots, but they're negative. So you can go ahead and see one all worked out here. You can go ahead and calculate it or verify if you would like to, but that's mathematically how we would find the inverse without a calculator. Now, good news for you is that we are actually just going to go straight to our calculator for these ones, and we're just going to say thank you and appreciate this technology here that we have that will do all of this for us. So with your calculator, basically you're going to type it in. So you're going to enter the matrix. Okay, and then what you're going to do is you're going to type the matrix name by hitting the second matrix and then finding the name of whichever one you're going to do. And then you're going to find the inverse button. And there is an inverse button on your calculator. So let's go ahead and enter this first one together and do it. So 3726. So we're going to go ahead and in matrix, we're going to go ahead and edit matrix A to be a 2 by 2. And it is 3726. So we're going to quit out of this. We've entered our matrix. We're going to go ahead and do matrix, and we want matrix A. And the inverse button is the same button as the matrix button, actually. So it's A inverse. And so when you type that in, you will get an inverse matrix. Now, say these were nasty decimals, and I said, hey, I don't want any decimals. I only want fractions. One really cool thing is that your calculator can turn all of those into fractions at the exact same time. So if you are getting nasty decimals as a matrix, you still do math frac and it will turn it into your fractions. So our answer for this one was 3/2, -7/4, -1/2, and 3/4. So your turn. Go ahead and try example 4. Type this in and find the inverse of A. So we should get 1/10, 1/25, -1/20, and 2/25. Now, in order to solve equations, we use inverse operations, which is why we're talking about inverse matrices. So inverse matrices help us undo matrix multiplication. Meaning, if you have two matrices, matrix A and matrix X, being multiplied together, to undo multiplication, what we have to do is the inverse of the matrix. So this undoes multiplication with matrices. So we're going to multiply both sides by A inverse. And when you're doing this, A inverse times A is the identity matrix, which then does not change your resulting matrix when you multiply it by something. On the right-hand side, though, you have to be careful with the order. Notice how the inverse is going on the left. So when you're undoing your matrices, the inverse matrix has to go on the left and be multiplied by whatever matrix is on the right. The order matters because it is not commutative with matrix multiplication. So you're going to have to type in A inverse of B on your calculator. So in order to solve for x, this is not something where you look at it and you say, hey, I'm going to divide both sides by that matrix. We don't have matrix division, because how do you divide something? Like, it doesn't, think about your matrix multiplication. To undo that process is pretty crazy. So what we're going to do here is we're going to say this is matrix A and this is matrix B. Right now these are being multiplied together. So to undo matrix multiplication, we're going to do matrix inverse. These two would cancel out, and we would say A inverse times B. So what we're going to do is we're going to enter this in as A on our calculator and enter this in as B on our calculator. So looking at this, you can go ahead and enter those in. So pause the video, enter those in, and then come right back. So those are now entered for me for A and B. So what we're going to do is we're going to hit second matrix, and we're going to pull up matrix A, but we want the inverse of matrix A, and we want to multiply that by matrix B. So you hit second matrix and you go down to B, and so you would go ahead and get -7, 1, 3, and 0. So x equals -7, 1, 3, and 0. That's how we would solve these matrix equations. So I know I'm going to use something like that whenever, again, I see a matrix times another matrix and I have to undo something. So let's try this one. Here we have matrix A and matrix B and matrix C. So to solve for this one, what I'm going to do is I'm going to subtract B to the other side. And it would be C minus B. Then what I have to do is I have to undo this by doing the inverse matrix C. So I'm going to go ahead and make sure that I'm grouping C minus B together. The matrix X would be the inverse of A times the quantity of C minus B. So let's now take a moment and enter A, B, and C on our calculator. And then after you enter A, B, and C, go ahead and enter this in on your calculator. So if we've entered A inverse parentheses C minus B, we should get these decimals. If your calculator is having an error with it, it might be an older calculator, and talk to me tomorrow. I'd be happy to show you how to work with that. And lastly, we can go ahead and turn those all into our fractions. So here would be our answer for this problem. Thank you very much for listening.